Ethan Fish, here to talk to you about Module 6, which is Modeling Electromechanical Systems. First, to start, we're going to need to know that we'll only have to do KCL, KVL, Kirchhoff's law. We'll also need to be able to solve for Newton's second law in these electromechanical systems. Okay, first we're going to start out with back electromotive force, which is back EMF. Current carrying rotating coils in magnetic field. So we will have current, which is our I here. We'll have a voltage, which is B times length times velocity. Then we'll have a force, which is B times length times your current. And then from that, we'll be able to calculate a torque value, which will be your constant times your current. Then we'll be able to solve for the back EMF, seen here, which will be the KB, which should be the constant, times d theta of m times t of t over dt, which is also equal to the constant times s theta m of s. So now here, we'll be solving for our transfer function, where we'll be taking a motor in a mechanical system and transition it down to a motor torque happening at the motor, which will be the load on the shaft, which will be an equivalent system based on simplifications of the math here on the left-hand side with Jm dm. Up here in the transfer function, you'll be able to see some constants, which will be derived from this shaft here with the Tm, theta m, Jm, dm, which is all seen in this equation here. One thing I would like to point out, though, before we continue on is when you look here at the Jm, dm, you'll see n1 over n2, which will be the destination over the source. That's how you get from down here to up here, which would be the destination. And you square that to transition that to make it one straight shaft. Now we're going to move on to our electrical constants. Here we'll be able to see that we have a torque speed, actually, which will be able to give us the torque speed curve over here on the right hand side, where we'll get those constants out of, actually. So where we get those Tm, omega m. Okay. We'll be able to find these variables for different EA terms. As you can see, there's two lines here. And then we can define our constants with a no load and stall torque. Excuse me. In solving for these equations, it's easier to do with the no load speed, because it simplifies the equations, and we'll be able to solve for that torque value much easier. Thank you.